Here in question number 5, three charges q minus q and q naught are placed as shown in figure. The magnitude of the net force on the charge minus q naught at point O is. So there is a point charge which is q naught present at the origin of this Cartesian coordinate system, and rest of the charges, one is negative charge minus q and another one is positive charge plus q present over here at a distance of separation a from the origin or from the q naught charge. So what will be the net force on this q naught charge? So first of all, we will try to find out the force due to individual charges. So force on q naught due to minus q charge, force on q naught due to this minus q charge, it will be equal to k q naught divided by distance of separation square. So that means it will be a square. As this is a negative charge and q naught is a positive charge, so there will be attraction between them, and the direction of this force on q naught due to minus q will be towards the given charge. It will be simply we can say towards the given charge. ये इसके तरफ रहेगा. Okay, just here this will be towards the given charge, and so magnitude wise the force will be this one, and similarly force on this q naught due to plus q charge magnitude wise, so it will be how much? तो ये जो plus q charge है, this for due to this plus q charge, what will be the magnitude of force? Again k q naught divided by distance of separation square a square, and as this is a positive charge, so there will be repulsion between them, then the direction of force will be away from the given charge. This will be away from the charge. Clear? Now we need to find out the net force. So net force will be resultant of these two. Clear? So net force will be what? Net force will be resultant of these two forces. Yes. So what will be the resultant of these two forces? So this will be the resultant of these two forces. Clear? As individually these two forces are perpendicular to each other, so the resultant will be F equal to under root. So this force square, that means here it will be F q naught minus q, or you can square plus F q naught q square plus 2 into F q naught q plus this is minus q, F q naught due to plus q cos theta. So the whole root of this one. So finally if you calculate this particular value, assuming that these two forces magnitude wise these two forces are same, so that means we can write magnitude wise F will be equal to F force on q naught due to minus q, magnitude wise force on q naught due to plus q, and let it be F. Clear? So if it is F, then what you can write over here, this force will be equal to F equal to, and another thing, angle between these two forces, these individual forces, is 90 degree. That means here cos 90 will become 0. So finally it will be F square plus 2 F cos 90. So this one becomes 0, so it will be 2 F square. So root of 2 F square, it will be nothing but root 2 times F. So if it is root 2 times F, then but we know that individual forces, magnitude of individual force is nothing but k q naught upon a square. So that net force will become this net force. This is the net force, F net. So F net finally comes out to be root 2 times F, that means root 2 times k q naught upon a square. So finally we'll check the option. So option this is incorrect. Root 2 times k q naught upon a square. So option C is correct, and this is also wrong.